Let's continue with the previous session about communication. Effective classroom communication techniques. Effective classroom communication is essential for creating a positive learning environment and promoting student engagement. Here are some techniques for effective classroom communication. Active listening. Active listening is an essential component of effective communication. It involves paying attention to what the other person is saying, asking clarifying questions, and responding appropriately. Researchers can demonstrate active listening by maintaining eye contact, nodding, and paraphrasing the student's comments. Nonverbal communication. Nonverbal communication involves using body language, facial expressions, and tone of voice to convey meaning. Teachers can use nonverbal communication to show empathy, interest, and understanding. For example, smiling, nodding, and using a calm tone of voice can help students feel more comfortable and engaged in the classroom. Clear and concise language. Teachers should use clear and concise language to communicate with their students. Using simple, straightforward language can help students understand the material and avoid confusion. Use of technology. Technology can be an active tool for enhancing classroom communication. Teachers can use tools such as video conferencing, online discussion forums, and educational apps to communicate with their students and promote engagement. Collaborative learning. Collaborative learning techniques can also promote effective communication in the classroom. Group work, peer tutoring, and classroom discussions can help students develop communication skills and learn from one another. Feedback. Providing feedback to students is an essential aspect of effective communication. Teachers should provide constructive feedback to students to help them understand their strengths and areas for improvement. Then, positive reinforcement. Positive reinforcement can also be an effective communication technique. Teachers can use positive reinforcement such as praise or rewards to motivate students and promote engagement in the classroom. Overall, effective classroom communication is essential for promoting student engagement and creating a positive learning environment. By using active listening, non-verbal communication, clear language, technology, collaborative learning, feedback, and positive reinforcement, teachers can communicate effectively with their students and promote success in the classroom. Reasoning. Reasoning is the process of making logical conclusions or inferences based on the given information. It involves using critical thinking, analysis, and problem-solving skills to arrive at a valid conclusion. Reasoning is an essential skill in mathematics as it helps in understanding the concepts and solving mathematical problems. There are various types of reasoning that can be applied in mathematics, including deductive reasoning, inductive reasoning, and abductive reasoning. Deductive reasoning is a type of reasoning that involves drawing a specific conclusion from a set of general premises. It is used extensively in mathematics as it provides a systematic and logical approach to problem solving. For example, if we know that all even numbers are divisible by 2 and that 8 is an even number, we can deductively reason that 8 is divisible by 2. Next, inductive reasoning is a type of reasoning that involves making a generalization based on a set of specific observations or examples. It is used in mathematics to develop conjectures or hypotheses that can be tested and proved. For example, if we observe that the sum of the first 10 odd numbers is 100, we can use inductive reasoning to generalize that the sum of the first n odd numbers is n square. Abductive reasoning is a type of reasoning that involves making a possible conclusion based on incomplete or limited information. It is used in mathematics to generate hypotheses or conjectures that can be tested and verified. For example, if we know that a number is divisible by 3 and the sum of its digits is also divisible by 3, we can abductively reason that the number itself is also divisible by 3. So a number is divisible by 3 and sum of its digits is also divisible by 3, then we will be reasoning that the number itself is also divisible by 3. In addition to this type of reasoning, there are various strategies and techniques that can be used to improve reasoning skills in mathematics. One of the most important techniques is problem solving, which involves identifying the problem, breaking it down into smaller parts and using reasoning skills to find a solution. Another effective technique is visualization, which involves creating mental images of mathematical concepts and problems to help understand and solve them. However, there are also several barriers to effective reasoning in mathematics. These include lack of understanding of the basic concepts, inability to apply logical reasoning, and difficulty in connecting mathematical concepts with real world situations. These barriers can be overcome by developing a strong foundation of the basic concepts, practicing problem solving techniques, and applying mathematical reasoning in real world situations. In conclusion, reasoning is an essential skill in mathematics that involves using critical thinking, analysis, and problem solving skills to arrive at a valid conclusion. It is a systematic and logical approach to problem solving that can be applied using various types of reasoning, including deductive reasoning, inductive reasoning, and abductive reasoning. By using effective reasoning techniques and strategies, one can overcome barrier to effective reasoning and develop a strong foundation in mathematics. Next, number series. A number series is a mathematical reasoning topic that involves a sequence of numbers with a certain pattern or rule. The challenge is to determine the rule and predict the next number in the series. The following are some steps to solve number series problems. Examine the series. First, examine the given series carefully to identify any pattern or rule that might be used to derive the next numbers in the sequence. Identify the pattern or rule. Identify the pattern or rule used in the given series. The rule may involve arithmetic operations like addition, subtraction, multiplication, or division, powers or roots, or combinations of these operations. Step 3. Apply the pattern or rule. Once the pattern or rule is identified, apply it to the last number in the given series to obtain the next number in the sequence. Check your answer. Check your answer by applying the rule to the next number in the series to confirm that they match the predicted values. For example, consider the following number series 1, 3, 5, 7, 9. Step 1. Examine the series. The given series consists of odd numbers, so we can infer that the rule may involve adding a constant number to the previous term. Then, step 2. Identify the pattern or rule. To confirm this, we can subtract each term from the next to obtain the sequence of differences. We can see that the common difference between each pair of term is 2. Therefore, the rule for this series is add 2 to the previous term to get the next term. Apply the pattern or rule. Applying this rule to the last term 9, we get 11 as the next number in the series. Check your answer. Checking the next term by applying the same rule gives 13, confirming that the pattern is to add 2 to the previous term. In conclusion, number series is a fundamental concept in mathematical reasoning that involves identifying patterns or rules to determine the next number in a sequence. By following the steps outlined above and practicing with various examples, one can develop proficiency in solving number series problems. Letter series mathematical reasoning. A letter series is a type of mathematical reasoning that involves a sequence of letters arranged in a particular pattern of sequence. The pattern may be based on a rule such as the position of the letters in an alphabet, the difference between their ASCII values, or the number of letters between them. Here is an example of a letter series A, C, F, J, and O. To solve the series, we need to look for the pattern or rule that is being followed. In this case, we can see that each letter in the series is increasing by a certain number of letters. The first letter A is followed by the third letter C, which is 2 letters away. The third letter C is followed by the sixth letter, which is 3 letters away. The sixth letter F is followed by the 10th letter J, which is 4 letters away. The pattern continues, so the next letter in the series should be 5 letters away from the previous letter, which is the 15th letter O. Therefore, the next letter in the series is the 20th letter T. Thus, the complete letter series is ACFJOT. Letter series are commonly used in aptitude tests, and they can be a good way to test a person's logical reasoning and pattern recognition abilities. By practicing letter series problems and understanding the different types of patterns that can be used, individuals can improve their mathematical reasoning skills and increase their chances of performing well in aptitude tests. Codes. Mathematical reasoning is a logical process of solving problems by using mathematical concepts and principles. Codes are one of the important aspects of mathematical reasoning, which involves Identifying patterns and relationships between letters, symbols, or numbers. A code is a system of symbols or signals used to represent a message in a secret or disguised form. In mathematical reasoning, codes are used to represent a set of rules or relationships that can be used to decode or encode messages. For example, let's take an example of a sample simple code. A, B, C, D, E, F. A is equal to 1, B is equal to 2, C is equal to 3, and etc. Using this code, we can encode or decode messages by replacing each letter with the corresponding number. For example, the word code would be represented as 31545, and the number sequence is like this, would be decoded as this. Number can be decoded like bouquet procedure. To decide a message using codes, we need to identify the pattern of relationship between the symbols or numbers. This can be done by analyzing the sequence of codes and looking for patterns or relationships between them. For example, in the code given above, we can see that each letter is represented by its position in the alphabet. Therefore, we can easily decode any message encoding using this code by simply replacing each number with its corresponding letter. Codes are useful in many areas of life, including cryptography, computer science, and communication. They allow us to encode and transmit information in a secure and efficient manner and can be used to protect sensitive information from unauthorized access or interception. Disadvantages. However, codes can also be vulnerable to attack if they are not properly designed or implemented. If a code is too simple or predictable, it can be easily detected. If a code is too simple or predictable, it can be easily decoded by an attacker who is able to identify the pattern or relationship between the symbols or numbers. In conclusion, codes are an important aspect of mathematical reasoning that allows us to encode and decode messages in a secure and efficient manner. They are used in many different areas of life and can be a powerful tool for protecting sensitive information. However, it is important to be aware of the potential vulnerabilities and limitations of codes and to use them in a careful and responsible manner. Then relationships, mathematical reasoning. In mathematical reasoning, relationship problems involve finding the relationship between the given elements or terms based on a certain pattern or rule. These problems can be solved by identifying the pattern or rule and then applying it to find the missing element of the term. Here are some examples. Find the missing term in the following sequence. A, E, I, M. Solution. The given sequence consists of vowels of the English alphabet. We can see that the letters are increasing by 4 in each step, so the missing term should be letter Q. Therefore, the missing term in the sequence is Q. Find the missing number in the following series. To find the missing number, we need to identify the pattern in the given series. Here we can see that the difference between consecutive terms is increasing by 1 in each step, so the missing term should be 23. Therefore, the missing number in the series is 23. Find the missing number in the following grid. To find the missing number, we need to identify the pattern in the given grid. Here we can see that the numbers in the first row are the squares of the first 3 natural numbers. The numbers in the second row are the squares of the next 3 natural numbers. So the missing pair should be 36, which is the square of the next natural number. Therefore, the missing number in the grid is 36. Next, classification is a type of mathematical reasoning problem that involves grouping or categorizing given objects or entities based on certain characteristics or features. The problem may provide a set of objects and ask the solver to identify which objects belong to the same group or category based on a set of rules or criteria. Here is an example of a classification problem. Which of the following words does not belong with the others? Apple, banana, carrot, orange, and mango. In this problem, we are given a list of 5 fruits and asked to identify which one does not belong in the others. To solve this problem, we need to identify the characteristics or features that define the group of fruits to which the other fruit belong. In this case, the fruit consists of fruits that are commonly eaten raw, while carrot is typically cooked before consumption. Therefore, the answer is option C, carrot. The procedure for solving a classification problem is as follows. Identify the objects or entities to be classified. Determine the characteristics or features that define the groups or categories. Analyze the objects or entities based on the characteristics or features. Group the objects or entities based on similarities or differences in the characteristics or features. Identify any outliers or objects that do not belong to any of the groups. Some tips for solving classification problems are: look for patterns or similarities in the objects or entities. Pay attention to details and subtle differences in the characteristics or features. Use logic and reasoning to identify the groups or categories. Classification problems are commonly found in various fields such as mathematics, logics, computer science, and psychology. In day-to-day life, we may encounter classification problems when sorting items based on their type of characteristics, such as sorting clothes by color or food items by their category. Next, logical reasoning. Logical reasoning refers to the process of using a systematic approach to solve problems by applying logical rules and principles. It involves identifying patterns, making inferences, and using deduction to arrive at a conclusion. Here are some tips and tricks to help you improve your logical reasoning skills. Practice regularity. Logical reasoning skills can be developed with the regular practice. Solve puzzles, brain teasers, and logic problems to sharpen your mind. Understand the question. Before attempting to solve a problem, it is important to fully understand the question. Read the question carefully and identify the key concepts and relationships. Identify the type of problem. Logical reasoning problems can be divided into different types such as sequencing, deduction, comparison, and analogy. Identifying the type of problem can help you apply the correct approach to solve it. Look for patterns. Logical reasoning problems often involve finding patterns or relationship between elements. Look for similarities and differences between the elements to identify the underlying pattern. Make inferences. Use the information provided in the problem to make inferences about the relationship between elements. Draw logical conclusions based on the evidence provided. Use logic rules. Logical reasoning problems follow certain rules and principles such as the law of syllogism and the law of contrapositive. Use these rules to make deductions and arrive at a conclusion. Use diagrams. Diagrams can be useful in solving logical reasoning problems, especially those involving spatial relationships. Draw diagrams or use visual aids to help you understand the problem. Eliminate incorrect options. In multiple choice logical reasoning questions, eliminate options that are clearly incorrect. This can help you narrow down your choices and increase your chances of choosing the correct answer. Stay focused. Logical reasoning problems can be complex and require concentration. Stay focused and avoid distractions to ensure that you don't miss any important details. By following these tips and tricks, you can improve your logical reasoning skills and solve problems more effectively. Understanding the structure of arguments. Explanation. Next topic. Understanding the structure of arguments is a key component of critical thinking and logical reasoning. An argument is a set of statements where one statement is presented as being supported by one or more of the other statements. The structure of an argument can be broken down into several parts, including the premise, the conclusion, and the reasoning that connects the two. Here is an example of a simple argument and how it can be analyzed in terms of its structure. All cats have fur. Fluffy is a cat. Therefore, Fluffy has fur. In this argument, the first premise is a general statement about cats, while the second premise is a specific statement about Fluffy. The conclusion is then drawn based on these two premises using logical reasoning to connect them. The reasoning used here is that since all cats have fur, the Fluffy is a cat, then it is logically follows that Fluffy has fur. To understand the structure of an argument, it is important to identify the premises, conclusion, and the reasoning based on used to connect them. Here are some simple tips and tricks to help you analyze the structure of arguments. Look for the conclusion first. The conclusion is the main point being made in the argument, so it is important to identify it before examining the premises and reasoning. Identify the premises. The premises are the statements that provide evidence or support for the conclusion. They may be stated explicitly or implied. Evaluate the reasoning. Once you have identified the premise and conclusion, you need to examine the reasoning used to connect them. Is the reasoning valid and sound, or are there any fallacies present? Look for counter arguments. It is important to consider alternate arguments or objections to the conclusion, as this can help strengthen the overall argument. Understanding the structure of arguments is an essential skill for critical thinking and logical reasoning. By analyzing the premises, conclusion, and reasoning used to connect them. You can evaluate the strength and validity of arguments and make more informed decisions in your daily life. Evaluating and distinguishing deductive and inductive reasoning, verbal analogies, word analogy, applied analogy. Verbal analogues are the essential component of various types of reasoning, including deductive and inductive reasoning. Analogies are comparisons between two different things or ideas, and word analogues, or in particular, are used to determine the relationship between words or concepts. Understanding the structure and evaluation of analogues is crucial in both deductive and inductive reasoning. Deductive reasoning is a type of reasoning that involves drawing conclusions based on premises or established facts. In deductive reasoning, the conclusion necessarily follows from the premise, which means that if the premises are true, the conclusion must also be true. For example, consider the following argument. Premise 1, all mammals are warm-blooded. Premise 2, whales are mammals. Concluded, whales are warm-blooded. In this example, the conclusion necessarily follows the premise and the argument is deductively valid. The evaluation of deductive arguments often involve identifying the structure of the argument and determining whether the premise supports the conclusion. Inductive reasoning, on the other hand, involves drawing conclusions based on observations or evidences. Inductive reasoning is used to develop hypotheses or theories based on empirical data. For example, consider the following argument. Observation: every crow that we have seen is black. Conclusion: therefore our crows are black. Observation is here and conclusion is here. In this example, the conclusion is not necessarily true, but it is based on the observed data. Inductive reasoning can be evaluated based on the strength of the evidence and the extent to which the conclusion follows from the evidence. Verbal analogues are often used in both deductive and inductive reasoning. Word analogues involve finding the relationship between two sets of words and then identifying a pair of words that has a similar relationship. For example, hand is to glove as foot is to shoe. The relationship between hand and glove is that a glove is worn on a hand. A similar relationship exists between foot and shoe. So the answer is shoe. Next, applied analogues involve using a non-relationship to understand a new or unfamiliar relationship. For example, if someone describes a difficult problem as being like a Rubik's Cube, the applied analogue suggests that the problem is complex and requires a systematic approach to solve it. In order to effectively understand and evaluate verbal analogues, it is important to identify the relationship between the words in the analogue and then determine if the same relationship exists between the answer choices. Additionally, it is important to be aware of common types of analogues such as synonyms, antonyms, cause and effect, and part and whole relationships. In conclusion, understanding the structure of arguments and the evaluation of deductive and inductive reasoning is crucial in effectively evaluating and using verbal analogues. By recognizing the relationship between words or concepts and applying that understanding to new situations, individuals can enhance their reasoning abilities and problem-solving skills. Next, evaluating and distinguishing inductive and deductive reasoning. Deductive and inductive reasoning are two methods of reasoning that are used in logical thinking and problem solving. The key difference between these two types of reasoning lies in the way they arrive at their conclusions. Deductive reasoning is a process of reasoning that starts with a general principle or statement and uses it to derive a specific conclusion. Inductive reasoning, on the other hand, is a process of reasoning that starts with a specific observations or evidence and uses it to arrive at a general conclusion. Example of deductive reasoning: all men are mortal, then Socrates is a man. Therefore, Socrates is mortal. In this example, the premise all men are mortal and Socrates is a man lead to the conclusion Socrates is mortal through deductive reasoning. Examples of inductive reasoning: observation: every crow I have seen has been black. Therefore, all crows are black. In this example, the conclusion is arrived at through inductive reasoning based on a specific observation. Procedure for distinguishing between deductive and inductive reasoning: identify the premises and conclusion of the argument, determine whether the premises lead necessarily to the conclusion or only probabilistically support the conclusion. If it probabilistically supports the conclusion, it's inductive. If it just necessarily lead to the conclusion, then it's deductive. Consider the strength of the premises and the likelihood of the conclusion based on the available evidence. Evaluate the soundness of the argument based on the strength of the premises and the degree of support they provide for the conclusion. Tips and tricks to evaluate deductive and inductive reasoning. Look for keywords and phrases that indicate deductive or inductive reasoning, such as therefore or deductive reasoning, and therefore it is likely for inductive reasoning. Consider the context and purpose of the argument to determine whether deductive or inductive reasoning is more appropriate. Evaluate the soundness of the argument based on the available evidence and the strength of the premise. Be open to revising your initial assessment by the argument as the new evidence or information becomes available. In conclusion, distinguishing between deductive and inductive reasoning is an important skill in logical thinking and problem solving. By understanding the characteristics of each type of reasoning and following the procedure and tips outlined above, you can more effectively evaluate arguments and arrive at sound conclusions. Next, verbal analogues. Verbal analogues are a type of reasoning question commonly found in aptitude tests, assessments, and exams. They assess a person's ability to recognize relationship between words and apply them to a new situation. In verbal analogues, two pairs of words are given, and the task is to find the relationship between the first pair and apply it to the second pair. For example, finger, hand, petal, flower. In this example, the relationship between the finger and hand is that finger is a part of a hand. Similarly, the relationship between petal and flower is that petal is a part of a flower. Understand the given pair of words and identify the relationship between them. Identify the relationship between the second pair of words. Apply the relationship between the first pair of words to the second pair of words. Look for the obvious relationship between the given pairs of words. Try to identify the categories to which the words belong, like living, non-living things, parts of a whole, synonyms, antonyms. Use the process of elimination to eliminate the options that do not fit the relationship between the first pair of words. Verbal analogues test a person's ability to think logically and make connections between concepts. By practicing with different examples, one can improve their skills in verbal analogues, which can be useful in various fields such as problem solving, decision making, and critical thinking. Word analogues. Word analogy is a type of verbal reasoning that involves identifying a relationship between two given words and using that relationship to determine a similar relationship between two other words. This is commonly found in standardized tests and an important skill for problem solving and critical thinking. A word analogy question, you are given two words that give a certain relationship between them, and you must find another pair of words that have a similar relationship. The relationship between the words can be of different types such as synonyms, antonyms, part, whole, cause, effect, etc. Key to solving these questions is to identify the relationship between the given words and then find a pair of words that share a similar relationship. For example, an example of a word analogy question is as follows: apple is a fruit, carrot is a vegetable. So it is like that. To solve a word analogy question, follow the steps. Identify the relationship between the two given words. Determine the type of relationship, like synonym, antonym, part, whole, cause, effect, etc. Use the identified relationship to find the similar relationship between the two other words. Check each option to see which one shares the same relationship with the given pair of words. Choose the option that has the most appropriate relationship. Next, tips and tricks. Read the question carefully to understand the relationship between the given words. Look for keywords or phrases that indicate the type of relationship. Eliminate questions that do not have a similar relationship to the given pair of words. If you are unsure about the answer, use the process of elimination to narrow down your choices. Word analog questions can be challenging, but with practice, you can improve your skills and develop the ability to identify relationships between words quickly and accurately. Next, applied analogy. Applied analogy is a type of reasoning that involves comparing two or more situations or objects that may not seem similar at first glance. It involves using knowledge and understanding from one situation to help understanding or solve a problem in another situation. Applied analogy involves comparing two things or situations that may appear differently but have certain similarities. In applied analogy, the similarities between the two situations are identified, then knowledge or understanding from one situation is used to help understand or solve a problem in the other situation. This type of reasoning is often used in science and technology, where understanding one process or phenomenon can help understand or improve another. A common example of applied analogy is the comparison of the circulatory system to a transportation system. In this analogy, the heart is like a pump that moves blood like cars through the blood vessels like roads to different parts of the body like cities. This analogy helps students understand how the circulatory system works by comparing it to something they are already familiar with. So, procedure to use applied analogy. First, identify two situations or objects that may not appear to be similar at first glance. Then, look for similarities between the two situations. Once you have identified the similarities, you can use knowledge or understanding from the situation to help understand or solve a problem in the another situation. Tips and tricks. Look for similarities between the two situations or objects. Try to identify specific aspects of each situation that are similar. Consider how knowledge or understanding from one situation can be applied to the other situation. Practice using applied analogy with a variety of different situations and objects. Applied analogy is an important tool in problem solving and can help us understand complex concepts by comparing them to things we are already familiar with. By using applied analogy, we can make connections between seemingly unrelated topics and improve our understanding of the world around us. Verbal classification. Verbal classification is a type of reasoning that involves organizing words or concepts into specific categories based on shared characteristics. Matching words. For example, if given the words dog, cat, and bird, a person might classify them into category of animals because they all share the characteristics of being living creatures. Here is an example of verbal classification. Which word does not belong with the others? Apple, banana, carrot, and orange. And this example, carrot does not belong with the others because it is a vegetable, while the other three items are fruits. Procedure. To successfully classify words or concepts verbally, it is important to follow a systematic procedure. Here are the steps to follow. Read the words or concepts carefully and make note of any shared characteristic or attribute. Identify the category to which the majority of the words or concepts belong. Determine which word or concept does not fit with the others based on its unique characteristics or attributes. Double check your answer to ensure it makes logical sense. Practice identifying categories in everyday life, such as grouping objects in a room or classifying different types of food. Look for clues within the words or concepts that may help you determine their category. Consider the context in which the words or concepts are presented to help determine their category. Be sure to carefully read and analyze all of the words or concepts before making a classification decision. Verbal classification is an important skill that can be used in many different contexts, including academic and professional settings. By understanding the explanation, example, procedure, tips, and tricks for verbal classification, individuals can improve their critical thinking and problem-solving abilities. Next, logical diagrams. Logical diagrams are visual representations used to illustrate relationship between objects or concepts. They are a form of reasoning in which you use diagrams to help you understand a problem or concept. Logical diagrams can help to simplify complex ideas and make them easier to understand. There are several types of logical diagrams, including Venn diagrams, Euler diagrams, and tree diagrams. In this essay, we will explain each of these types of logical diagrams, provide examples, and offer tips and tricks for using them effectively. Venn diagrams. Venn diagrams are used to illustrate relationship between sets of objects or concepts. They consist of overlapping circles, with each circle representing a set. The area of overlap represents the objects or concepts that are shared between the sets. Venn diagrams can be used to identify similarities and differences between objects or concepts. In a Venn diagram, you may have one circle representing dogs and another circle representing cats. The area of overlap would represent pets that are both dogs and cats. To create a Venn diagram, draw overlapping circles that represent the sets you are comparing. Label each circle with the set it represents. Fill in the area of the overlap with the objects or concepts that are shared between the sets. Then, tips and tricks. Use different colors to represent each set to make the diagram easier to read. Label each set clearly to avoid confusion. Use a ruler to make sure the circles are accurately drawn and overlap correctly. Then, Euler diagrams. Euler diagrams are similar to Venn diagrams but use lines instead of circles to represent sets. They are typically used to illustrate relationship between multiple sets of objects or concepts. In a Euler diagram, you may have three sets represented by three different shapes. The lines connecting the shapes would indicate the relationship between the sets. To create a Euler diagram, draw the shapes that represent the sets you are comparing. Use lines to connect the shapes and indicate the relationship between the sets. Use different shapes to represent each set to make the diagram easier to read. Label each set clearly to avoid confusion. Use a ruler to make sure the lines are accurately drawn and connect the shape correctly. Tree diagrams are used to illustrate hierarchical relationships between objects or concepts. They consist of a root node at the top with branches representing subcategories or subtopics. Tree diagrams can help to break down complex ideas into smaller, more manageable parts. In a tree diagram, you might have a root node representing animals with branches representing mammals, birds, and fish. The branches for mammals might then have sub-branches for cats, dogs, and humans. To create a tree diagram, start with the root node at the top of the diagram. Draw branches that represent subcategories or subtopics. Continue adding branches and sub-branches as needed to break down the concept or idea. Use different colors to represent different levels of hierarchy. Label each node clearly to avoid confusion. Use a ruler to make sure the branches are accurately drawn and connected to the correct nodes. In conclusion, logical diagrams are a powerful tool for reasoning and problem solving. By understanding the types of logical diagrams and how to use them effectively, you can simplify complex ideas and make them easier to understand. Whether you are a student, a professional, or just someone who enjoys puzzles and problem solving, logical diagrams can help you think more critically and creatively. Thank you for listening.